CERN, the European Organisation for Nuclear Research, is pressing ahead with plans to build a colossal new particle collider on the Swiss-French border. The Future Circular Collider, or FCC, would be more than 3 times the size of the Large Hadron Collider, a machine used to discover the Higgs boson in 2012. The FCC would require boring a circular tunnel 91 kilometers in circumference, 200 meters underground. It would encircle an area bigger than Chicago and deliver high-energy particles to 4 huge experimental holes. The total cost is estimated at $17 billion. A full study of the project will be published next year with a go or no-go decision expected before 2028. Construction could begin as early as 2033. The planned machine would collide electrons with their anti-counterparts, positrons, from around 2045 with the aim of generating and studying large numbers of Higgs bosons. Many physicists think that studying this particle in detail represents the best chance of finding cracks in the Standard Model, a hugely successful but incomplete model of fundamental particles and forces. The FCC would allow researchers to explore the Higgs boson and the so-called Higgs field in great detail. It would aim to smash subatomic particles together at a maximum energy of 100 TeV, that's trillion electron volts, 7 times greater than the Large Hadron Collider, which maxes out at 14 TeV. If the Future Circular Collider is approved, it would be built in 2 stages. The first experiments would collide electrons and positrons, while the second phase, earmarked for the 2070s, would enable protons to be smashed into one another. Other designs for so-called Higgs factories are in the works elsewhere. In Japan, there's interest in hosting the International Linear Collider, while China has set its sights on a machine called the Circular Electron-Positron Collider. Not everyone in the high-energy physics community is in favor of CERN's proposed new machine. Some think that an alternative technology for future colliders based on colliding beams of muons might be a better way to go. Muons are much more massive than electrons, allowing for higher energy collisions, but no one knows yet whether building a muon collider is even possible. Some scientists argue that the cost of building enormous colliders outweighs their benefits, especially when theory gives no clear indication on what might be discovered or how. Since the Higgs breakthrough in 2012, the LHC hasn't revealed any significant new physics that might shed light on some of the deepest mysteries of the universe. We're keen to learn the nature of dark matter and dark energy, and why matter dominates over antimatter. Is the FCC the best way to go? Will it be approved? Time will tell.